Hi guys, I am Hongyi and this is Houxuan. We are from Group 1 of 327. Our project for this course is a haptic feedback smart knob, which is based on a BLDC motor.
So let's jump into the project description. Our project focuses on building a virtual knob with a brushless DC motor while providing like real feedback, also known as haptic, like this. We'll build 3D print all the shells and cases inside supporting parts for connecting PCB and the motor and the outside part for spinning in high resolution. So for the beginning, we'll build a proper prototype with a magnetic encoder chip, which can sense the magnetic field, and an LED light, both connecting to ESP32, controlling the LED dimming and lighting manually with a magnet. So for ESP part, we will use the interpreted PWM controller to modify the brightness of the LED. And after this, we will print out the holder for motor and replace the magnet wheel with a real BLDC motor. Then add haptic part, polish the details, and finally finish the whole project. And we made several design choices. So firstly, when we were brainstorming, we are very confused because the prototype is largely based on what components arrives first. Then we ordered a substitution for encoder, which is not as good as the former one, but it will arrive earlier. So we just to build a prototype with it to control the LED lights brightness. And we're now in milestone 2, and next week we will finish milestone 2 and go into milestone 3. It's like build a knob prototype to test the functionality of motor and build PWM code. And for items, we have an LCD, which is displaying the information, and encoder for detecting the motor's position, and LED light for this ring to display the situation, and the motor itself. And we also want to add an ambient light sensor for controlling automatically the LED's brightness, the LCD screen's brightness with ambient light, and a piece of glass protecting the LCD, also the driver, and this is the substitution of the magnetic encoder, and also a high resolution ADC for clicking the motor. So
And I will finish the rest part of this presentation. We've done some market research for this product, and we believe that our target audience would be those aged between 18 and 35, because we believe they are more open to new technologies, to smart house technologies, and so we assume they will accept our idea of smart knob more smoothly. And nowadays, there are actually some competitors in the market of smart home. For example, the Siemens Connected Home, which is very popular and well-known, and also Apple Siri and Amazon Alexa. Those two mainly focus on voice recognition and voice control. And also Google Home. And now that we have many competitors in this market, we want to make our product better. So we interviewed 2 people for some advice on our idea. The first interviewee said that we can use the smart knob for a smart home. That's for sure, because that's our original plan. And also the smart knob can be used reversely. For example, it can be controlled by scales to show our body weight. And we can also add a safety mode to prevent force touch from kids. And the second interviewee said that we can use it as a switch hub for different switches at home. And we can also add ambient temp sensor and humidity sensor for sensing room environment. We can control AC, air conditioner, and humidifier automatically with some kind of algorithm. Okay, so far we have discovered something very useful and new to us. For example, the first one is the Python website framework, which is Tornado. And that is new to both of us, and we are still working on that. The second one is to use PWM on ESP32, which I think is also very helpful to you guys if you want to use it. We think it's rather simple to use PWM on ESP32, and we only need 3 functions. The first is the setup function, LEDC setup. We will set up the PWM channel and the frequency for this PWM wave, and also the resolution of the duty cycle. And the second function is to attach this channel to a specific pin, to a specific GPIO port. This is LEDC attach pin function. And the third function is LEDC write function. In this function, this is a function that really output the PWM wave. After we call the function, we can detect the PWM wave at the assigned port. So in this function, we need to set the duty cycle value. It should be noted that the duty cycle value should not exceed the resolution, the maximum value of the resolution. For example, if our resolution is 8 bits, so the duty cycle should not exceed 255, which is the maximum value of an 8-bit digit. And here is an example of a PWM wave. We use it to create a breathing light effect. We set the LED pin to GPIO 16 and the frequency as 5000, and LED channel is 0, and the resolution for the duty cycle is 8. In the setup function, we set up the channel frequency and the resolution and attach the channel to the pin we've assigned. And in the main loop, we gradually increase the value of the duty cycle and then decrease it to realize the effect of breathing light. That is the simple piece of code. So I think that is all we want to deliver for our presentation. We have 2 questions for you guys. The first question is, what do you think of the applications of our smart knob? For example, if we use it for a smart home, do you think it's very practical to control everything in our home with just one knob? And the second question is, for our initial prototype, we plan to use a piece of magnet to imitate the magnetic field of the BLDC motor, and we can use it to test the magnetic encoder. Currently we don't have a better choice because we haven't received the motor yet. So we have to hold the magnet with our hand and rotate it manually to change the magnetic field. So I wonder if you guys have a better idea for the test. We would very appreciate it if you leave some comments. And
thanks, guys. This is the end of our presentation.
Yes, thank you for all you guys, and we hope you are getting well with your project as well. Yeah, good luck.